Hello, everybody. My name is Ashwin John, and today we'll be looking at the equilibrium chapter, and specifically, we'll be looking at the ice equations. Now, the ice equations are a particular favorite of the IBs, and they really like to include a few of these questions that are worth at least 4 to 5 marks. So it's really well worth your time to go through this video thoroughly. Okay, so let's begin. We have a question before us. A student placed 0.4 moles of PCl3 and 0.2 moles of Cl2 with a 1.0 decimeter cube flask at 350 degrees Celsius. The reaction which produced PCl5 was allowed to come to equilibrium, at which time it was found that the flask contains 0.24 moles of PCl3. What is the value for Kc? Okay, so what would you do? What would be your first step for such a question? Now, you have to first think about writing the overall chemical equation for this. Excuse me. The overall chemical equation for this question. Now, the overall chemical equation for this question is simply going to be, as we can see from the question itself, PCl3 plus Cl2, equilibrium sign, gives you PCl5. Now this can clearly be observed from the equation. There are no additional compounds that have been added that are hidden, so to speak. Now your second step would be to utilize the ice antonym. So what ice stands for is basically just initial change in equilibrium. Now, what would be the initial number of moles for PCl3? 0.4, right? What would be the initial number of moles for Cl2? 0.2. For PCl5 is nothing for now. What would be the change is what we'll get to later. What would be the equilibrium number of moles for PCl3? 0.24 moles of PCl3, right there. Now, what change needs to be brought about in order to bring 0.4 down to 0.24? Well, you use the handy calculator here. So we use a calculator, and yeah, so 0.24, 0.4. So 0.4 minus x is equal to 0.24. Will be 4 minus 0.4. So 0.16 is your answer. Minus 0.16. So it's minus here. So if it's minus 0.16 there, it'll be 0.16 here. And over here, it would be plus, because you can't have a negative, can we? At least that's the way I like to remember it. You can't have a negative value for the equilibrium. So 0.2 minus 0.16, 0.04, and no need for calculator there. Now, our next step is our third step is to find the Kc value, or the value for Kc. which is really your question there. So your equilibrium constant, or Kc, as can be observed from the equation, is going to be PCl5 over PCl3, your reactants basically, and Cl2. Now, using this, we just substitute it into the equation. PCl5 0.16 over, don't forget the brackets, 0.24 and 0.04. Now, what is the answer going to be? 0.16 divided by 0.24 minus 0.04. Answer is 16.67, or in this case we just round it up and make it so it's 16.7 or 17. And that is exactly how you find the value for Kc. Remember guys, it's extremely easy. Your first step is to write the chemical equation. Your second step is to use the antonym of the IC equation, initial change equilibrium. Your third step is to find the value for Kc. Okay? There are harder problems than this, but I hope that I've at least taught you the basics in this instance. Thank you very much, and I'll see you in the next video.